All right, well, good afternoon, everyone. Welcome back to another exciting day of mathematics. Warm-up 90s on the screen, very similar to the one we did yesterday. So let's finish up, please. Shouldn't take you long. Copy and go. All right, so far so good, yes? Bless you. All right, copy the agenda for today. On the screen, leave your Chromebooks open. We are going to need them for the sesh. Today, warm-up number 90. And like I said, today we're going to finish up this chapter, and we're going to be combining everything together from probability rules and counting rules all together in one problem. So hopefully that's going to make a little bit of sense once we get started. Your home plate for tonight is 4.5. The exercise at the end of that session, numbers 1 through 12, odds only, odds only. All right. So, y'all ready to finish this up? Yes, Mr. Q, we love this. All right, good. So, our objective for today, I can identify and compute basic probability. I can identify and compute basic probability. Like I said, we're going to wrap this up today, so stay focused because it's a lot to cover in regards to, it's going to cover everything we've seen with probability. So, let's see where we're at. Remember when we started with probability that you came up, you're like, oh yeah, I know the definition of probability. So turn to your neighbor, let them know what a definition for probability is. What is probability? All right, JC, what's probability?
The event, or the chance of an event occurring.
Yes, the chance of an event occurring. And we saw 3 different types of probability. Tell your neighbor the 3 different types. Very good. Classical, empirical, and subjective. Tell your neighbor which 2 did we work the most with. All right. Since you already know which ones they are, tell your neighbor the formula for each of those. And by the way, these are the simplest ones, the simplest ones. All right, good job. There they are on the screen. The probability of an event. We have the number of outcomes for the event, but the bottom one is the total outcomes. That's for classical. For empirical, it's basically the same, but it's in regards to frequency because this is the one that we use for an experiment, right? Where we actually did the die or the dice activity in class. Remember that? And classical is more of you get the problem just straight from the paper. Okay. Where else? The rules. What other rules? Oh, all these. 1, 2, 3, 4, and complementary rules. Now, mind you, you already have all this. You don't need to write it down, right? I'm just reviewing and refreshing your noodle because we're going to need all these. Now, imagine combining in one problem all of these, and you need to pick. All right? From there, we went to what? Exclusive and not exclusive. So we did addition rules. From there we went to multiplication rules. Remember these? Yes? Multiplication rules. Multiplication. Yes? Okay. Then from there we went to conditional rules. Yes? Oh yeah. From there we went to counting rules. Tell your neighbor the 3 counting rules. Very good. Yeah, fundamental, permutation, combination. All right? And tell your neighbor the difference between, oh, we already know that the fundamental is the factorial, yes? But tell your neighbor the difference between permutation and combination. Permutation and combination. Yeah, very good. And there they are. Look how pretty those are, yes? All right. So with that said, y'all ready to combine everything in one? You're like, no. Yes, you are. Copy, and I'm gonna start us off by using the basic and the classic, formula, which is the probability of an event, where the bottom is the total number of outcomes. But we're gonna combine that now with counting rules. You're like, what? Oh yeah, copy this. Example number 1. Copy the problem, please, so like that you can have it as an example. And it reads, a store has 6 TV graphic magazine and 8 news time magazines on the counter. If 2 customers purchase a magazine, find the probability that one of each magazine was purchased. Copy that. So, it says, a store has 6 TV graphic magazines and 8 news time magazines on the counter. If 2 customers purchase a magazine, find the probability that that one of each magazine was purchased. Okay. So, and let me go back to the previous formula. What formula did we say we're going to start with? The classic probability one, this one, yes? So write this one down on the side or at the top, just so that we can have it as a reference. So remember, the bottom is always the total number of outcomes. Okay. So, what are they asking us for? The probability that 2 customers purchase a magazine, that one of each magazine was purchased. So let's write, I'm going to write it right here. P of, what kind of magazines do we have? Very good. I'm just going to write TV and news time, NT. Okay. Start with a total of the totals. So, how many magazines are going to be purchased? One of each, which means a total of how many? 2. Okay. Now, question to you. This is where we start combining with counting rules. Does the order matter? No. So therefore, we're going to use what? Exactly. Combination. So, what is the total number of magazines that we have at the store? How many? 14. And how many are going to be sold? 2. Okay, there it is. All right, next. It says there that the 2 customers purchase the magazine. One of them has to purchase at least one customer purchases one of each, one of one, and the other one purchases the other one. So let's see. How can we write this? Talk it over to your neighbor. If I was to use the same formula, but on top, how can I write that? Does the order matter? No, so we write C. So how many total for the TV magazines? 6. And how many are going to be sold? 1. Okay. But in this case, since we have 2 different ones, we need to multiply that times the next one. What is the next one? Tell your neighbor how to write the next one. Yeah. 8, 1. With that said, you know your formulas. Find me the probability of that. I'll give you some time. Go. I'm sorry, I was assuming you guys were on the ball already. So, can somebody give us the formula for combination? Let's see, JC, pass them one.
Jet.
Jet, go. Yeah. Factorial then, okay. But from the beginning. The what? NCR, okay. Factorial then. That is correct. So you use that for each of these, and then on the numerator, you multiply whatever you get for for the TV, and then for the news time, and let's see what that gives. Copy and go. All right, let's see. I'm going to do the one in blue. Let's see if you're following along. We got 6, combination 1. You should have written 6 factorial over 6 minus 1 factorial times 1 factorial. Yes? Yes, Mr. Q. So then we end up with 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 1 is 5 factorial, so that's 5 times 4 times 3 times 2 times 1, and then 1 factorial, 1. Oh, sorry. 1 factorial, and of course we know these are giant ones, so we end up with 6 over 1, which is 6. Hands if you got 6. All right, so far we got 6 times 8 combination with 1, so we got 8 factorial, 8 minus 1 factorial times 1 factorial. And again, 8, 7, 6, 5, 4, 3, 2, 1 over 8 minus 1 is 7, 7, 6, 5, 4, 3, 2, 1 times 1 factorial, giant ones. So this is 8 over 1, which is 8 over. So far so good, yes? And the bottom one, 14 combination 2, yada, 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 blah, blah, blah. You should have 14 times 13 left, is that correct? So what is 14 times 13? And then divided by 2? Is that correct? Is that 14 times 13? What'd you get, Mel? 1 what? 182. Divided by 2, that's 91. So, the probability of one of each magazine being sold is 48 over 91. Hands, have you got that? Yes? All right. Woo-wee. Pretty good, pretty good. All right, send me your notes, hold on. Problem number 2 reads, a box contains 24 transistors 4 of which are defective. If 4 are sold at random, find the probability of exactly 2 defective. All right, this is going to require a little bit of thinking. Similar to the one we just did, but just a bit tweaked. So, question, let's start with the total of totals. Tell your neighbor what you would write for the total of totals. Does the order matter? No? Okay. So therefore, what would you write for the total of totals? All right. Check with your neighbor, see what they're writing for their total of totals. Yes, I heard 24C4. That is correct. That's the total of totals. Okay. So, how many are sold? 4. Okay. But how many are we checking to see if they are defective? 2. Okay. So let me ask you this. Let's start with how many are defective. How many total are defective? So how can we write that 2 of them that they sell out of 4? How can we write that? That is correct, 4C2. Times. Okay, so if we already accounted for the 4 of them that are defective, and 4 of them are being sold, that means this is only accounting for how many? 2. So how can we write that exactly 2 are defective? What do you think we would write? Remember, this is the total of totals. This is how many are defective. Talk to your neighbor, let them know what would you write here. There's a little bit thinking to do. Let's see, what would you write, Mel? It's 20C2. Because we're extracting what? All the 4 of them, right? All right. So with that said, do the computation. The rest is just computation. I'll give you some time and go. You will need some big numbers, so you might need a calculator. Go. All right, for the sake of time, let's see. What'd you get for this part right here? Zach? Oh, sorry, hold on. 6 times, what'd you get for this part, JC? 190? C2? Okay. All right, and for the bottom part, what'd you get, Cheney? 626. Hands if you got up to right there. Looks about right. All right. So this is 0, 4, 11. And this reduces to what? 1140 divided by 10, 626. Can it be reduced? What'd you get? Like that? 300? All right. From 1 to 5, how comfortable are you with this so far? 4, 5, 4, 5, okay. And I think this could be reduced a little bit more. Let's see, what is 5 plus 7? 12. What is 5 plus 3 plus 1 plus 3? 12. 12 and 12, I think they have a factor of 6, so I think we can reduce by 6 still. FYI. But I'll leave it right there. All right? And look at this one, example number 3. This is the last one. And it reads the same. It's the same problem except for find the probability of non-defective. So let me get you started. Just write example 3 for that same problem that you just wrote down and write P. What are we looking for? Yeah, no defective. This one's a little bit more simpler because there's only one way of writing no defectives, right? Let's see if you can set it up by yourself. All right. Help us with the denominator, total of totals. Alejandro, what do I write? Uh-huh. Yes, 24 and 4, because still 4 are sold, yes, out of the 24. So, talk it over to your neighbor, let them know, how do you write the probability of none being defective? None being defective. If 4 of them are sold, but 4 of them within the 24 are defective. Talk it over to your neighbor. How would you write that? Yeah, you got to keep in mind, there's still 4 of them that are defective, and there's 24 total. Once again, if you have questions, ask Samuel. He's got it. Let's see, what you get on the numerator, Samuel? That is correct. All right, find me that, please. Let's go, let's go. Finish it up. All right, so the probability of no defectives, give me the last numbers, last number on the numerator, last on the denominator. What'd you get for that? Pass someone? Samuel? I'm sorry, I couldn't hear. 1,600 and what? 15? Over? 3,000? 42. Hands if you got that. Looks about right. And we'll stop right there. Once again, this was just to culminate everything that we've seen with probability up to right now. Tonight's home play, like I said, try and get some practice in. Now, tomorrow is Friday, but it's the end of the quarter, so tomorrow is just going to be like a day that we do like an activity in groups. Is that okay? Yeah? All right. Mel, you good with that? Man, you're giving me that stare. Wow. Anyways, I'll stop the video right there. Those of you that are joining us online, just get some practice in from somewhere. Talk to you guys later. Bye.